Okay, what'll come up here is what we did on Friday, and we looked at some groups. And the first group we looked at, and I gave you some looks of it, was sodium's group, which is the first column. Now, I did this for you guys. I don't know if I rewrote this for period 7 or not, but you probably should have real similar statements down so you can check yours out compared to these. They are extremely reactive. They react with water and oxygen. They're a +1 charge when they become an ion. So an ion is just an atom that's charged. They'll lose an electron when they react. They have a small density. Actually, it's less than the density of water because they float. And they're a pretty soft metal. I could cut that sodium in that. And they tend to form compounds that are basic, and that's why they call it an alkali metal. So, questions you guys have on that group? And then something else I'm going to add to it is that they're never found, they're not found by themselves in nature. Okay? So, not found, I'm going to put this in quotes, free in nature. They're always bound up with something. Okay? Don't have to worry about the circles in that there. They get a lot more reactive as you go down the group. So potassium's more reactive than sodium, and rubidium's even more reactive than potassium. They're more unstable as you go down the group. They're really unstable. Anything sets them off. Okay? Yeah, other than some things that can stabilize them. Then we have this next group, and it's called the alkaline earth metals. They're fairly reactive, but not as reactive as the alkali metals. They're going to give up 2 electrons when they react. Most react with either water or acids. So they're going to be reactive with water. I think I did the calcium one for you. You guys remember that one? Kind of started out slow, and it picked up speed, and it started bubbling a little faster. These here are not found free in nature either. They're too reactive with things around them. So they're always going to be found combined with something. You're not going to find calcium. The pure now, there's some things that calcium ions, but those are different than the pure form of calcium. Any questions on that? Okay, so that's the alkaline. And so they're going to form basic solutions too. They're going to form bases as well. Okay? Then we have our last 2 groups. Okay? Got the halogens. Okay? These are all toxic or poisonous in the pure form. Okay? I've got some of those that are sealed up. I'll show you guys. And hand it around so you can see what they look like. It doesn't take much of breathing these in that you're going to get sick real quick. It might have permanent damage to your lungs if you breathe enough of them in. So this is examples of bromine, chlorine, and iodine. And I don't have fluorine, but fluorine's kind of like chlorine. It's kind of got a yellow, fluorine's kind of got a yellow tint to it. Okay, so I'm going to hand this around. Don't drop it, okay?
So if those were break,
I don't think there's enough. I think if the bromine broke, it would be kind of messy to clean up because it's liquid. But if the chlorine broke, it's such a small amount that it's going to spread out through the room and it's not going to be a big deal. Okay? If you notice it, as it comes around, fluorine's a gas, chlorine's a gas, bromine is a liquid at room temperature, but you can see that it doesn't stay a liquid very well because if you look at the container, the outside of the container above the liquid's really brown. And then iodine, you can see a purple tint to it too. So you don't have to, look at it for a while. You don't have to pass it on right away. If you're interested in looking at it, it's not like we're taking a whole really fast notes and that you have to keep up. All right? I want you to enjoy that coming around, just to kind of see the differences between the two. They will gain one electron when they react. Okay, so when they react, they're gonna pick up an electron. They're opposite. I'll come back to this page, but they're opposite of these metals. These metals, they either give up 1 or 2 electrons. Like the alkaline metal gives up 1 electron. The alkaline earth metal gives up 2 electrons. And the halogens will gain an electron.
So how do they know it gains something when it reacts? Like how do they measure that?
That's a good question. How would you measure that? And they just kind of do it on net charge. They can kind of figure out what the net charge is. And they can realize what the charge of an electron is, and then if they pick up an extra one, they can figure out what that
So
is.
there's not like a tool or anything that...
There is. I don't know what that would be, what you could use, but there is a tool that you could figure out the net charge of it. So when they gain 1 electron, they're going to be negative charge as an ion. So they're going to be a -1 charge as an ion. So they're going to be -1 when then they become stable. They're really unstable in that form that's being passed around. What does it mean by unstable? Unstable means that they're not going to stay in that form very long. They're going to switch and they're going to pick up electrons. So they are said to be strong oxidizing agents. Chlorine and bromine and iodine are strong oxidizing agents. What that means that they pull electrons away from other elements. They do a great job of pulling electrons away from other elements. And that's kind of what they do. And they get more, fluorine, they're all really unstable. Okay. Any questions you have with that group? The halogens. Okay. All right, and then I'm going to go ahead and put the noble gases down here. But the noble gases are right next to a very reactive group, and these are very unreactive. So we can say all are unreactive. They will not gain or lose electrons. Will not gain or lose electrons. And so when you look at your chart, they're going to be the ones that are 0 charge. The fluorines, when we write those up there, fluorine, chlorine, bromine, and iodine, they're a -1 charge. So that group's a -1. Okay, and then we can say that they're very stable elements. In fact, they're so stable that they're used to put things into them that are unstable. So that you would put things that are unstable with them to stabilize them. So like, you could put the sodium with that gas and it's not going to do anything. It kind of insulates it from other elements that might do something to them. Okay, they're all gases at room temperature as well. Okay, and then the last thing I'll have you put down, not found in any compounds. I got one more thing to do too, it's not very long. And then they're found free in nature. So they're found by themselves. Okay, found free in nature.
Where is that bottom one found?
Found free. Now that free doesn't mean money-wise. It means that they're found by themselves. They were the last group of elements that were located comparatively to the other ones in their row. They were the last ones that were found. Because they couldn't be isolated from a compound. They're just naturally in the air. And then if you cool the air cool enough, then you can isolate them down. But you have to get them really, really cold to do that. Okay. Some of these later ones are found in compounds. I think xenon's found in a compound. But pretty much the rest of them, they're not found. They're found by themselves. All right, so we have that information that I give you. We're going to do a little activity. It won't take us very long. Okay. In your notes, we're going to go ahead and look at question number 4 on page 63. We're just going to look at question number 4 on 63. That's the only one we're going to really look at. So, I have selected elements up here. And these elements are coming from the NAI. So everything that's listed out there in question number 4 has NAI, MgCl2, CaO, Al2O3, CCl4. Okay? So, what I have up here is all those elements. And we're going to go ahead and make some predictions. You guys will actually make the predictions on your paper. And we'll see if you predict right. I'll help you out with the first one. Okay? So, the first one, it wants you to predict what the formula would be of C and F. So, here's C. And then here's F. Okay? So do we have a compound that has elements in those two groups? Up above. Do we have a compound that we can compare C and F to that's similar to C and F? Up above. No. What we're looking at are those 5 formulas up in question number 4. Look at those formulas that's in question number 4. NAI, MgCl2, CaO, Al2O3, or CCl4. What compound would you look at to make a prediction of what that formula is going to be? Which of those 5? So we're going to come up with a formula of C and F put together. So which formula would be the best one to look at? You have to look at the groupings. Okay, I'll go down the line. Would you look at NAI? Here's Na. And here's I. Would you do that one?
No.
No. Okay. Next one, MgCl2. Here's Mg and Cl.
No.
No.
Probably
Okay.
CaO.
Yeah,
Okay.
C-
So
C-
which one? The Ca
Yeah.
Cl4, right?
CaO.
C- C-
Okay. Well, we look at Ca. Ca's here and O's here. You wouldn't look at that because they're not in the same grouping. Okay. So Al's here and O's here. That wouldn't be the case. What about C and Cl?
Yeah.
Yes. So if the formula is CCl4, what would be the formula for CF? CF4. Does you guys agree with that? Here's CCl4, okay, which is here and here. So it just makes sense if it combines with Cl that way, it's going to combine with F that way because they're in the same family. Okay. Now that you got that one, I want you to predict Al and S. Write the formula for Al and S based upon those examples above. Okay? Okay, anybody think they have a possible answer? So here's Al and here's S. Ready?
Al2O3.
Yes, so you would say Al, you would look at Al2O3 because the O is in the same column as S, so you would predict this would be Al2S3, right?
Yes.
Yeah.
Okay, so do the last two. Last three. Do C, D, and E. Okay, I'll give you time to do that. C, D, and E. Make predictions of what you think the formula is going to be. You guys need to write them down too. You need to commit it. Write them down somewhere. C, D, and E. Write them down. See if you get them right. Based upon those first two examples.
You mean the last
You
three?
guys, and you guys need to probably have your periodic table out so you can look to see where they're located. Okay. So
What letter again?
So some of you guys are struggling because you don't have anything in front of you. Like I showed you where they were at. Now you guys got to have your periodic table out. Look at it so you can see what column they're in. Because otherwise, you're not doing a very good job of making a good prediction. So get your periodic table. You have one in the back of your book.
We're on page 60.
Yep, you got page 60. You got the page before that.
What number? What?
We are doing 4, C, D, and E. 4, C, and D, and E on page 63.